Taylor series method for numerical solution of ordinary differential equation. Suppose we have a differential equation, first order differential equation dy dx equals to f of x comma y at the point x0. At the point x0, value of y is y0. At the point xn, what is the value of y? Okay. So this is the first order differential equation dy dx equals to f of x comma y. The initial condition is at the point x0, value of y is y0. At the point xn, what is the value of y? We have to calculate the value of y at the point xn. Now first calculate h, that is a step length, that is xn minus x0. Okay, we take h equals to xn minus x0 for Taylor series expansion. Okay, for Taylor series method. Okay, so for Taylor series method, we take h equals. For Taylor series method, we take h equals to xn minus x0. Okay, for Taylor series method for numerical computation of first order differential equation dy dx equals to f of x comma y, we take h equals to xn minus x0. Now, what is Taylor series? Taylor series at around the point x0 with step length h or radius h, y x0 plus h equals to y x0 plus h y dash x0 plus h. This is Taylor series. Okay, y x0 plus h equals to y x0 plus h y dash x0 plus h square by 2 factorial y double dash x0 plus h cube by 3 factorial y triple dash x0 plus h to the power 4 by 4 factorial y4, mean fourth order derivative of y at the point x0 plus dot. Okay, this is Taylor series around the point x0 with radius h. Okay, based on this Taylor series theorem, based on this Taylor series theorem, we will compute the value of y at the point xn. Okay, just write one problem. Okay, right. Compute y 0.1 and y 0.3. Compute y 0.1 and y 0.3 from the differential equation. dy dx equals to x into y minus 2. Compute y 0.1 and y 0.3 from the differential equation dy dx equals to x into y minus 2 with initial condition y bracket 0 equals to 3. Okay, comma correct to 5 decimal places. Correct to 5 decimal places. So you have to compute y 0.1 and y 0.3 from this differential equation dy dx equals to x into y minus 2 with initial condition at the point 0, value of y is 3. Correct to 5 decimal places. We will use Taylor series method. So for Taylor series method, for the differential equation dy dx equals to f of x comma y, this is the differential equation, first order differential equation, and the initial condition at the point x0, value of y is y0, and question is at the point xn, what is the value of y? Okay, so here fxy is x into y minus 2. So f of x comma y is x into y minus 2. F of x comma y is x into y minus 2. And x0 is 0, x0 is 0, y0 is 3, y0 equals to 3, x0 is 0, y0 is 3. Okay, and xn is the point where we will have to calculate y. So this is the point xn. So xn equals to first we take xn equals to 0.1, then or 0.3. First we will solve y at the point 0.1, then we will solve y at the point x equals to 0.3. Okay, these are the given input. So first calculate h. H equals to, for Taylor series method, we will take h equals to xn minus x0. So h is 0.1, for this case 0.1 minus 0. So h equals to 0.1. For the first case, we take h equals to 0.1. Okay. Now the given differential equation is dy dx, that is y dashed equals to x into y minus 2. Dy dx is what? Y dashed, that is given x into y minus 2. So the y dashed is xy minus 2x. Okay. Then calculate y double dashed. Y double dashed is xy dashed plus xy dashed plus y minus 2. So y double dashed is xy dashed plus y minus 2. Then y triple dashed, that is xy double dashed plus 2y dashed, xy double dashed plus 2y dashed. This is y third order derivative. This is second order derivative with respect to x. This is third order derivative with respect to x. Okay, y dashed is xy minus 2x. So they just differentiate both sides with respect to x. So y double dash, that's it, d2y dx2 equals to xy dash plus y minus 2. Next, differentiate with respect to x once more. So y triple dash is xy dash plus y dash plus y dash. So it is 2y dash minus 0. Okay, next y4 is xy triple dash plus 3y dash. So y4 is xy triple dash plus 3y dash. Next y5, that is xy4 plus 4y triple dash. xy4 plus 4y triple dash. Okay. So y dash is 2x, xy minus 2x, y double dash is xy dash plus y minus 2, x triple dash, third order derivative of y is xy double dash plus 2y dash, fourth order derivative of y is xy triple dash plus 3y dash, fifth order derivative of y with respect to x, that is xy fourth order derivative of y plus 4 into third order derivative of y. Okay, now x0 is 0. So y dash 0 equals to just put x equals to 0. Just put x equals to 0. So it is 0 into y minus 2 into 0. So it is 0. So y dash 0 is 0. Y dash 0 equals to y dash 0. Just when x equals to 0, y dash 0 equals to 0 into y minus 2 into 0. So it is 0. Now y double dash 0 equals to x is 0 plus y dash, that is also 0. Y double dash 0 equals to x0 into y dash 0 is 0 plus y at x equals to 0 is 3 minus 2. So it is 1. Say y double dash 0. Y double dash 0 is 0 into y dash 0. 0 into y dash 0. Y dash 0 is 0 when x equals to 0 into y double dash 0. See, this is 0, x is 0 into y dash, x equals to 0 plus y at x equals to 0 minus 2. So y double dash 0, y double dash 0 equals to 0 into y dash, x equals to 0 is 0 plus at x equals to 0, what is y? At x equals to 0, y is 3 minus 2. So it is 1. So y double dash 0 is 1. Y double dash 0 is 1. Just write y double dash 0. Y double dash 0 is 0 plus 3 minus 2. It is 1. Okay. Next. Y triple dash 0. Y triple dash 0. Y triple dash 0 is x, y double dash 0. X is 0. Y double dash 0 is 1 plus 2 into y dash 0. Y dash 0 is 0. So it is 0. Y triple dash 0. Y triple dash 0, 0 into y double dash 0. Y double dash 0 is 1 plus 2 into y dash 0. Y 0 is 0 is 0. So it is 0. Okay. Next. Y40. 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 Y40 is 0. 0 into y triple dash 0. Y triple dash 0 is 0 plus 3 into y double dash 0. 3 into y double dash 0. Y double dash 0 is 1. So Y40, see, Y40 equals to x. X is 0. 0 into Y30. Y30 is 0 plus 3 into Y20. Y20 is 1. So it is 3. So Y40 is 3. Y40 is 3. Next, Y50 equals to x0 0 into y40. Y40 is 3 plus 4 into y30. Y30 is 0. So it is 0. So Y40 is also 0. Okay. Now Taylor series around the point x0. Taylor series around the point x0 is, just write Taylor series of y at x equals to 0.1 at xn, at x equals to 0.1 with at Taylor series around the point 0, at Taylor series around the point 0 with h equals to xn minus x0. H equals to xn minus x0, that is 0.1. Okay. So Taylor series around the point x0. Taylor series around the point x0. Taylor series around the point x0. Taylor series of y around the point x0, that is 0, with radius h is, that is f of x0 plus h, or you can write y x0 plus h equals to Taylor series of y around the point x0. Taylor series of y around the point x0 with radius h, that is y x0 plus h y dash x0, y x0 plus h y dash x0 plus h square by 2 factorial y double dash x0 plus h cube by 3 factorial y triple dash x0 plus h to the power 4 by 4 factorial y4 x0 plus h to the power 5 by 5 factorial y5 x0 plus dot dot. This is Taylor series around the point x0 with radius h. Okay. So y, now what is x0 plus h? x0 plus h is xn. Xn is what? x0 plus h. So yxn is yx0 plus h y dash x0 yx0 plus h y dash x0 plus a square by 2 factorial y double dash x0 plus h cube by 3 factorial y triple dash x0 plus h to the power 4 by 4 factorial y4 x0 plus h to the power 5 by 5 factorial y5 x0 plus dot dot. This is Taylor series expansion around the point x0. Okay. Now xn is 0.1. So y 0.1 equals to yx0. Yx0 is y0. X0 is 0 plus h. H is 0.1 into y dashed 0 plus 0.1 square by 2 factorial y double dashed 0 plus 0.1 cube by 3 factorial y triple dashed 0 plus 0.1 to the power 4 by 4 factorial y4 0 plus 0.1 to the power 5 by 5 factorial y5 0. Okay. H is very small number, so you can neglect the higher order terms. We are considering only 5 up to order of h. Order of h equals to 5. We are taking order of h equals to 5. So y 0.1 equals to y0. Y at the point 0. Y at the point 0 is 3 plus 0.1 into y dash 0. Y dash 0 is 0 plus 0.1 square by 2 factorial is 2. Y double dash 0. Y double dash 0 is 1 plus 0.1 plus 0.1 cube plus 0.1 cube by 3 factorial. 3 factorial is 6. Y triple dash 0. Y triple dash 0 is 0 plus 0.1 to the power 4 by 4 factorial is 24 into y4 0. Y4 0 is 3 plus 0.1 to the power 5 by 120 into y5 0. Y5 0 is 0. Okay. Just simplify. So y 0.1 is y 0.1 equals to, this is 3.00501. 3.00501. Correct up to 5 decimal. Correct to 5 decimal places. Correct to 5 decimal places. Therefore, y 0. This is by Taylor series. So y 0.1 equals to 3.00501. Correct up to 5 decimal places by Taylor series method. From the differential equation, dy dx is x into y minus 2 with initial condition at the point 0, value of y is 3. Okay. Now we have one more part for this question. We have to calculate y 0.3. Y 0.3. Now for y 0.3, this is xn. Okay. So yxn is what? Yxn is xn is 0.3. Xn equals to 0.3. For that case, xn is 0.3. So h is what? H is xn minus x0. So it is 0.3 minus. For the second part of this question, we have to compute y 0.3. That is xn equals to 0.3. So h is xl minus x0. So h is 0.3 minus x0. x0 is 0. So it is 0.3. For the second part of this question, h is 0.3. Okay. Now we know that yxn is what? yx0 plus h y dash x0 plus h square by 2 factorial y double dash x0 plus h cube by 3 factorial y triple dash x0 plus h to the power 4 by 4 factorial y4 x0 plus h to the power 5 by 5 factorial y5 x0. We are considering only order of h equals to 5. Okay, since h is very small number. So y0.3 equals to yx0, that is y x0 is 0 plus h is 0.3 into y dash 0 plus 0.3 square by 2 factorial y double dash 0 plus 0.3 cube by 3 factorial y triple dash 0 plus 0.4 to the power 4 0.3 to the power 4 by 4 factorial y4 0 plus 0.3 to the power 5 by 5 factorial y5 0. Okay, so y0.3 equals to y0 is 3 plus 0.3 into y dash 0 is 0 plus 0.3 square by 2 factorial, that is 2, y double dash 0 is 1 plus 0.3 cube by 3 factorial is 6 into y triple dash 0 plus 0.3 to the power 4 by 4 factorial is 24, y4 0 is 3 plus 0.3 to the power 5 by 5 factorial is 120, y5 0 is 0. Okay, just simplify this expression. So y0.3 equals to 3.04,602. Correct to 5 decimal places. This is by Taylor series method. So y0.3 is 3.04,602, correct to 5 decimal places by Taylor series method. Okay, now we'll take one more problem related to Taylor series method. Okay, now we'll take one more problem related to Taylor series method. Right. Problem 2. Compute y1.2. Compute y1.2 from the differential equation dy dx equals to x into y. Compute y1.2 from the differential equation dy dx equals to x into y with initial condition y bracket 1 equals to 2. With initial condition y brackets 1 equals to 2. So compute y1.2 from the differential equation dy dx equals to x into y with initial condition y bracket 1 equals to 2. Okay, comma correct to 5 decimal places. Correct to 5 decimal places. Correct to 5 decimal places. Hence Hence find absolute error. Hence find absolute error. Okay. So you have to find exact value and the approximate value. Approximate value from this differential equation using Taylor series method, and we can solve this differential equation, and we can calculate the exact value of this value at the point y x equals to 1.2. Okay. So for this differential equation, y dash dy dx. So fxy is what? fxy is x into y. fxy is x into y. What is x0? This is the point x0. x0 is 1. What is y0? y0 is 2. Okay. And what is xn? xn is 1.2. These are the given data. Okay. fxy is x into y. fxy is x into y. x0 is 0. x0 is 1. y0 is 2. xn is 1.2. So calculate h. h equals to xn minus x0 for Taylor series method. So it is 1.2 minus x0. x0 is 1. So it is 0.2. So h is 0.2 for this problem. Okay. Now dy dx is y dash, that is given x into y. Okay. So first calculate y double dash. Y double dash is xy dash plus y. Y double dash is xy dash plus y. Next, y triple dash, that is xy double dash plus 2y dash. Y triple dash is xy double dash plus y double dash, 2y dash. Next, y4 mean fourth order derivative. This is second order derivative of y with respect to x, that is xy dash plus y. Third order derivative of y with respect to x is xy double dash plus 2y dash. Fourth order derivative of y with respect to x is x y triple dash plus 3y double dash. Next, the fifth order derivative y5 equals to xy 4 plus 4y. Okay. Now, what is x0? x0 is 1. So calculate y dash x0. x0 is 1. y dash x0. x0 is 1 now. So y dash x0. So x0 is 1. When x0 is 1, y0 is 2. When x is 1, y is 2. So y dash is x into y. So y dash 1. This 1 is x0 point. So y dash x0 is x0 into y0. x0 is 1 and y0 is 2. So it is 2. Y dash x0 equals to x0 into y0. So x0 is 1, y0 is 2. So y dash 1 is 2. Next, y double dash x0. x0 is 1. So it is 1 into y dash x0. y dash x0 is 2 plus y at the point x0. y at the point x0 is that is 1 at the point y at the point x equals to 1 is 2. So it is 4. See, y double dash x0. y double dash x0 is x0 into y dash 0. x0 is 1, y dash 0, y dash x0 is 2 plus y at the point x0. y at the point x0 is 2. So it is 1 into 2 plus 2, 4. Next, y triple dash 1. y triple dash 1 is x0. x0 is 1, y double dash x0. y double dash x0 is 4 plus 2 into y dash x0. y dash x0 is 2. So it is 8. So y triple dash 1 is 8. Next, y4 x0 is x0, that is 1 into y triple dash x0, that is 8 plus 3 into y double dash x0. y double dash x0 is 4. So it is 12 plus 8, 20. Next, y5 x0. That is x0 into y4 x0. y4 x0 is 20 plus 4 into y triple dash x0. y triple dash x0 is 8. So it is 52. Okay. Now, by Taylor series method, by Taylor series method, y xn, that is y x0 plus h, equals to y x0 plus h y dash x0 plus h square by 2 factorial y double dash x0 plus h cube by 3 factorial y triple dash x0 plus h to the power 4 by 4 factorial y4 x0 plus h to the power 5 by 5 factorial h to the power 5 by 5 factorial y5 x0 plus dot dot dot. Okay. So y xn is what? Xn is 1.2. Y 1.2 equals to, that is y x0. Y x0 is y bracket x0 is 1, y bracket 1 plus h is 0.2 into y dash 1 plus 0.2 square by 2 factorial y double dash 1 plus 0.2 cube by 3 factorial y triple dash 1 plus 0.2 to the power 4 by 4 factorial y4 1 plus 0.2 to the power 5 by 5 factorial y5 1. We are neglecting the higher order terms from h equals to 6 onwards. Okay. Now put y1. y1 is y at the point x0 equals to 1. That is y1 is 2. So this is equals to, so y 1.2 equals to y at the point 1 is 2 plus 0.2 into y dash 1. y dash 1 is 2 plus 0.2 square by 2 factorial is 2 y double dash 1. y double dash 1 is 4 plus 0.2 cube by 3 factorial is 6 y triple dash 1. y triple dash 1 is 8 plus 0.2 to the power 4 by 4 factorial is 24 y4 1 is 20 plus 0.2 to the power 5 by 5 factorial, that is 120 into y5 1 is 52. Okay, so this is equals to y 1.2, that is y 1.2 is 2.22 1421. This is 2.2214. Sorry, this is 2.22. This is 2. Sorry, this is 2. Just y 1.2 is 2.49215. 2.49215 in bracket, correct to 5 decimal places. Correct to 5 decimal places. Correct to 5 decimal places. Okay. So y 1.2 is 2.49215 correct to 5 decimal places. Okay. This is the approximate value of y. This is the approximate value of y at the point 1.2 connect up to 5 decimal places. This is 2.49215. 2.49215. Okay. Now we have to calculate absolute error. So first we need exact value. The differential equation is what? The differential equation is dy dx equals to x into y. Dy dx equals to x into y. Okay. So dy by y equals to x dx. So ln y equals to x square by 2 plus ln c. ln c is indicating constant. So ln y by c equals to x square by 2. ln y by c is x square by 2. So ln y equals to x square by 2 plus ln c. That is ln y by c equals to x square by 2. ln y by c equals to x square by 2. Now given initial condition is y bracket 1 equals to 2. Y bracket 1 equals to 2. Mean when x equals to 1, y is 2. So ln 2 by c is 1 square by 2. It is minus half. So ln 2 by c, so it is c by 2 equals to minus half. ln 2 by c is half, so ln c by 2 is minus half. That is c by 2 equals to e to the power minus half. So c is what? 2 into e to the power minus half. 2 into e to the power minus half. So c equals to 2 into e to the power minus half. Okay. Now from here, from this equation, ln y by c equals to x square by 2. ln y by c equals to x square by 2. We can find y is what? Y equals to c into e to the power x square by 2. From here, y is c into e to the power x square by 2. Now c is what? 2 into e to the power minus half. So y equals to 2 into e to the power minus half into e to the power x square by 2. So y equals to 2 into e to the power x square minus 1 by 2. Okay, this is the exact solution. Y equals to 2 into e to the power x square minus 1 by 2. This is the exact solution. Okay. Now, the approximate value, this is the approximate value at the y at the point 2, 1.2. So the approximate value is, that is y 1.2 equals to 2.49215. This is correct to 5 decimal places. This is by Taylor series method. Okay. Now Vt, the exact value Vt equals to, just put x equals to 1.2 here. So 2 into e to the power 1.2 whole square minus 1 by 2. 2 into e to the power 1.2 whole square minus 1 by 2. Just simplify. This is 2.49215. 3461. 2.49215. Okay, this is exact value and this is approximate value. So absolute error is what? Mod of Vt minus Va. Absolute error is mod of Vt minus V. So this is equals to 2.49215. This 53461 minus approximate value, that is 2.49215. So this is equals to, absolute error equals to, this is equals to 3.461 into 10 to the power minus 6. So absolute error A equals to 3.461 into 10 to the power 3.461 into 10 to the power minus 6. This is the absolute error. Okay. So before we stop today's class, just take one problem as homework. Just write compute. Okay. Take one problem as homework. Compute y 0.3. Compute y 0.3. Compute y 0.3 from the differential equation. Compute y 0.3 from the differential equation. From the differential equation, dy dx equals to x plus. Sorry, this is dy dx equals to x into y minus 2. Compute y 0.3 from the differential equation. Dy dx equals to x into y minus 2. Dy dx equals to x into y minus 2. X into y minus 2, comma, correct to 5 decimal places. Correct to 5 decimal places. Correct to 5 decimal places. Take h equals to 0.1. Take h equals to 0.1. So for this problem, first you have to compute y given, the initial condition is y bracket 0 equals to 3. So the question is compute y 0.3 from the differential equation. Dy dx equals to y 0 x, dy dx equals to x into y minus 2 with initial condition y bracket 0 equals to 3, correct to 5 decimal places. Take h equals to 0.1. The question is compute y 0.3 from the differential equation. Dy dx equals to x into y minus 2. Given initial condition is y bracket 0 equals to 3, correct to 5 decimal places. Take h equals to 0.1. So first calculate, for this problem h is given. See, here h is given. So first we have to calculate y x0 plus h. That is y 0 plus 0.1. So it first calculate y 0.1. Okay? First calculate y 0.1. Then consider this x as x0. That is from y 0.1 calculate y 0.2. Taking h equals to 0.1. Okay? So from x0 point, taking x0 as initial point, calculate y at the point 0.1. Then take x0 equals to 0.1, then calculate y at the point 0.2. Now taking x0 equals to 0.2, then calculate y at the point 0.3. Okay? H is given 0.1. So for this problem, you have to calculate first. y 0.1. Then from y 0.1 calculate y 0.2. Then from y 0.2 calculate y 0.3. Okay? So take this problem as homework. Okay? Next day we will start Euler method. Okay.